when you look at the demonstration, you'll see the same results. It's not that you've done anything wrong. Okay? So when he's talking about the modelling, the time to be done,
Okay, so people are already experimenting with different oscilloscopes. There's a nice Tektronix one that looks like a real one, with different coloured traces on it and so
so
on.
you can put 1,000 votes in that and 10 kilohertz. But then when
Give you a few more minutes to play about with that. Remember the challenge is, where does it go to about half? So how do you know what you're putting in? Well, you've got a 2-input oscilloscope there already. So have a look at the input, which will be right up, and have a look at the output, and on the VCR. Okay, anyone got any major headaches with that? Because we're going to move on to something which is a bit more useful. Because the last thing you want to do is sit there. You can do with a signal generator, and quite often I will do with a signal generator, increase and decrease the frequency and watch the output waveform change in the output view. That's a normal thing to do. But inside the simulator we can do something much more powerful. We can do a single experiment which allows us to see all frequencies at the same time. In other words, what I can do is I can plot this graph, which is ultimately what I want to do. So I can take my circuit and I can plot this graph. You could do it, but you'd have to do a measurement here, a measurement here, a measurement here, a measurement here, and so on. So you have to do lots of individual measurements and then extrapolate those measurements and then you can plot the graph. Let's see what Multisim can do for us. We start to see the power of simulators when we start doing things like this. So leave your circuit as it is, there's no harm in that. Remember to stop it, which is something I always forget to do.
we all do.
And it can also make your circuit crash as well. So if you leave that running and you try and do something else, there's a danger that you may lose to your last save. So if you spent ages doing it, I'm not going to do it here because I'm not particularly fussed if I do lose it. But save it. Save it now. Okay? So put it on your M drive, put it on your USB stick, make sure you've got that circuit. Because you'll want to come back to it. Tomorrow you will have forgotten. Okay, all got a say on that? So now what I'm going to do is I'm going to go to place, and I'm going to go to connectors. So you see what I've done there? I'm just holding over connectors that turn blue, and I've got a whole series of different connectors I can use. Yeah? I'm going to carefully go down to the third one that says hierarchical connector. then once I've got hierarchical connector, I'm going to click on it, and there it is. It's stuck on the end of my mouse again. Okay, I'm going to plonk that down anywhere. I don't care at the moment. And I'm going to go for another one. I'm going to place, connector, hierarchical connector, and I'm going to put that pretty much anywhere. You can see it's auto-labelled as IO2. I can double click on it and change the name if I wanted, but I don't care. So I'm just going to leave it like it is. Now I don't like the fact that the connector seems to be lying horizontally. I want it vertically. So I'm going to click on it, right click, rotate 90 degrees clockwise, and I'm going to do the same with the other one. Click on it, oops, not the name of it, the whole thing. Click on it, rotate 90 degrees clockwise, and then bring it in somewhere close to where I want to put it. And the same with this one. Now I can connect it up. So I connect on the end, click to where I want to go to, click on the end, click to where I want to go to. I'm going to press the run button for something to do, and lo and behold, the waveform does exactly what it did before. What a waste of time that was. Or was it? So now I'm going to stop the simulation, and I'm going to go up the top here where it says simulate. See that button along the top? So go to simulate, and below that it says analyses and simulation. I'm going to click on analysis and simulation, and you'll notice down the side there are an enormous number of options there. DC operating point, AC sweep, transient, DC sweep, single frequency AC, and so on and so on and so on. The ones that are probably most relevant to you are DC, although we're not going to do any DC simulations in here, are AC and transient. Now an AC analysis is something that says, right, we'll take a signal generator, we'll start at low frequency and we'll turn it up to high frequency and we'll plot the graph. That's what an AC analysis is. A transient analysis is we'll take a circuit and we'll hit it with something. It might be the edge of a square wave, it might be a block of a sine wave, it might be a block of a triangular wave or something. But we hit it. And why do you generally hit things? Or why do I just hit the table? If I've got my eyes shut, I know that that's made of wood because of the way it rings. If I tap the side of a car, I know it's a car because it's the way it rings. If I hit a bell, I know it's a bell because of the way it rings. So that's what you're doing to electronically to a circuit. You're hitting it to see how it rings. That's a transient. We're not going to do a transient yet, but I am going to do an AC sweep. So I click on AC sweep. And you can see I've got frequency parameters here. So my start frequency, it says here is 1 Hertz. Well, I'm happy with 1 Hertz, so that means, 0 Hertz would be what? 0 Hertz is? DC, thank you, you're talking to me now. So 1 Hertz, so I've got a sine wave that's going very, very slowly up and down once a second. That's okay. But my stop frequency is 10 gigahertz. Now remember, on my circuit, you may have different values on your circuit, but on my circuit I could see nothing beyond about 10,000 cycles a second, 10 kilohertz. So I don't, so what's gig? Times 10 to the, that's right. So I don't want to go 10 to the 9 because I'd end up with a graph where all the action was in the far left-hand corner and there was a lot of nothing in the right-hand corner. So I'm going to go down here and I'm going to click on kilohertz. So I'm happy to start at 1 Hertz, I'm happy to stop at 10 kilohertz. Now the sweep type, so in other words, the horizontal axis, the AC, the frequency axis, I could set to decade, I could set to octave, I could set to linear. I'm going to leave it as decade for the time being, but I invite you to do some experiments with it in a minute. Number of points per decade, this is going to give you the accuracy of your plot, and you all know when you plot a graph, the more points you have, the smoother it gets, the less points you have, the more spikes it has, and so on. I'll leave you to play about with that as well. And the vertical scale at the moment is set to logarithmic, but again there's several options in there that you can take. I'm going to leave it at the default option at the moment. Now I click on the Output tab, and I see a series of things. I can see that I've got I, which is C1, I've got R1, so it's indicating to me that I can measure the current at C1, the current at R1, the current at V1. But what I'm most interested in is you can see here, look, you've got the voltage at IO1 and the voltage at IO2. Well, why do you think I place these pads? Because that's what I'm interested in. So I'm going to click on V at IO1 and I'm going to click Add. And you notice it's disappeared from the left-hand side and it's now on the right-hand side. Can you see that? I'm going to do the same for the voltage at IO2. I'm going to select it, well it's already selected, and I'm going to press Add and it appears on the right-hand side. Okay, I'm happy with that so far. Now if I press the Run button, look what I get. Isn't that pretty? Isn't that pretty? So what it's telling me is that the magnitude here starts off at 1, and as the frequency increases, the amplitude drops off to 0, and the phase starts off leading by 10 and ends up by lagging by nearly, or about thereabouts 90 degrees. Can you duplicate that for me? And can you also play about the axis a little bit, because I haven't got that very good, because there might be something happening at the end of this graph here that I'm not seeing. So I might want to go to 100k. So I shut down the window, go to Simulate, Analyses and Simulation, I go back to the AC, go to the output,